Welcome to my YouTube channel, Cybernexus. I'm Shanmukhi Suma, and here we learn all about networking, cybersecurity, and technology, explained in the simplest way possible. Today, we're diving into one of the most important topics in networking, the OSI model and the TCP/IP model. Now let's talk about the OSI model, which stands for Open Systems Interconnection Model. The OSI model is a conceptual framework that helps us understand how data travels through a network. It breaks down the entire process into 7 distinct layers, each with its own role, from sending raw bits over cables to delivering data to your applications like web browsers or email. By dividing network communication into layers, the OSI model makes it easier to design, troubleshoot, and understand complex networks. The 7 layers of the OSI model are physical, data link, network, transport, session, presentation, and application layer. Let's dive into these layers step by step. The physical layer is the first layer of the OSI model. It's responsible for the transmission of raw bits, ones and zeros, through physical media like cables, switches, and network cards. Next up, the data link layer. Think of it as the traffic controller of your network. It takes raw bits from the physical layer and packages them into frames, ensuring that data is sent and received without collisions or errors. It's responsible for MAC addresses and Ethernet communication. Now we reach the network layer, the layer that gives every device an address and decides the best route for data to travel. Imagine it as a GPS for your data packets. Protocols like IP, the Internet Protocol, work here, guiding data from source to destination across the world. Moving up to the transport layer, the delivery manager of the OSI model, it makes sure your messages arrive complete and in order. Whether it's a video stream using UDP or a reliable file transfer with TCP, this layer guarantees that data gets where it needs to go, just the way it was sent. The session layer is like the host of a meeting. It opens communication sessions, keeps track of who's speaking, and closes the session when the conversation is over. Without it, your computer wouldn't know when one chat ends and another begins. Now we enter the presentation layer, the translator of the OSI model. It makes sure data from one system can be understood by another. This layer handles encryption for security, compression for efficiency, and converts data into readable formats. Finally, at the top, we have the application layer, the layer you actually interact with. When you browse the web, send an email, or stream music, you're using this layer. It connects real-world applications to the network and makes communication possible. Now, let's explore the TCP/IP model, which stands for Transmission Control Protocol and Internet Protocol. This model is the foundation of the modern Internet, the practical framework that makes global communication possible. The TCP/IP model defines how data is packaged, addressed, transmitted, routed, and received across interconnected networks. It breaks down the process of communication into 4 distinct layers, each with a specific role, from the physical movement of bits to the delivery of data between applications. In short, the TCP/IP model is what turns the Internet from an idea into a reality. The TCP/IP model is made up of 4 main layers: the application layer, the transport layer, the Internet layer, and the network access layer. Each layer plays a key role in how data moves across networks, from the physical transmission of bits to delivering complete messages between applications. In the diagram, you can see the original TCP/IP model on the left with 4 layers, while the updated version on the right divides the network access layer into 2 separate layers, the data link and physical layers, for more detailed representation. At the foundation of the TCP/IP model is the network interface layer, where data physically moves across cables or wireless signals. It handles how devices access the network and how bits are sent as signals. Think of it as the road on which all network traffic travels, whether it's through copper wires, fiber optics, or the air. Above it, we find the Internet layer, the brain of the network. This layer gives every device an address and decides how data finds its way from one network to another. The Internet Protocol, or IP, lives here, acting like a global postal system that ensures your data reaches the right destination. Next comes the transport layer, the messenger that ensures smooth delivery. Using protocols like TCP and UDP, it decides whether your message should be delivered reliably or just sent as fast as possible. From video calls to file downloads, this layer keeps communication flowing just right. Finally, at the top, we have the application layer, the face of the Internet. This is where users connect with the network through apps like browsers, email clients, and streaming platforms. Protocols like HTTP, DNS, and SMTP work here, making the web, email, and media streaming possible. And that's a wrap on the TCP/IP model, the backbone of modern networking that keeps the internet running smoothly. We learned how its 4 layers work together to move data from one device to another, reliably and efficiently. If you found this helpful, don't forget to like, share, and subscribe for more tech and networking lessons. Thanks for watching, and see you in the next video.